Welcome, lovely students, to our video tutorials. We have now finished with 3 set problems, and I was very happy that most of you understood it. You sent me comment that you have really understood it, and in fact, I was very happy. That is how it is. Please, from time to time, make sure you solve problems so that you keep refreshing until you face your examination. Keep practicing. Today we're looking at quadratic functions, and from here we go to polynomials, then we go to rational functions, and then we'll move on. The general quadratic function is of the form as squared plus bx plus c. This is a general quadratic function or expression. If I equate it to 0, then I get equation, quadratic equation. Good. Now, a, b, and c are constant, which means they are values, and a can never be 0. It cannot be equals to 0. This one cannot be 0. You know why? Because if a is 0, I get 0 times a s squared, and then 0 times s squared will give me 0. So if a is 0, then it means this thing will not be there. I'm going to get only this. And if I get only this, this will not be quadratic, because a quadratic expression should have a power of 2. The highest degree of an expression is the power, the highest power, or the powers of the expression. Here the degree is 1, that's s to the power 1. Here the degree is 2, s to the power 2. So all quadratic expression will have the highest power to be 2. Okay, that is to the degree of 2. Good. So this cannot be 0, else we will not have a quadratic expression. Good. Now the a is also very important in determining the shape of the quadratic function when we graph it, when we draw a graph for it. Now this a, if it is positive, then it means it's greater than 0, because all positive numbers are greater than 0. If it is negative, then it is less than 0. Okay, now if a is positive, which means it's greater than 0, then we are going to have a graph like this, U shape. Okay, and if a is negative, which means less than 0, then we'll have a graph like this, N shape. Okay, if a graph is U shape, then we are going to have a minimum value. That's what I put here. Okay, you can see if a is greater than 0, the function will have a minimum value. And if a is less than 0, which is negative, then the graph will have a maximum value. Okay, the minimum and the maximum value are the y values of the points here. So if we take the point here, we call it the turning point. Okay, this is the turning point. And you know that every point is made up of 2 coordinates, x and y, a point. Okay, so the turning point, the y value, if you look for the y value on the y-axis, this is the y-axis, the y value is called the minimum value. And the s value, which passes through the yellow line, is called the axis of symmetry. So the yellow line here you see is called the axis of symmetry. Axis of symmetry. Axis of symmetry. What is axis of symmetry? Axis of symmetry divides the graph into 2 equal halves. You remember lines of symmetry in JHS? Lines of symmetry, how many lines of symmetry as a square, rectangle, those things. They divide the shape into 2 equal halves. So here too we have the yellow line being the axis of symmetry, and where it passes is the turning point. The axis of symmetry will always pass through the turning point, and there when you trace the y value will be the maximum, because this is N shape, maximum, and the s value will be the axis of symmetry. Remember, the graph can even pass here, it can pass here, it can pass here, it can be like, it doesn't matter where it passes, as long as it is U shape, it will have minimum value, because on the y-axis here, as you go down, the values become small. and on the y-axis here, as you go up, the value becomes big. So that's why this one is maximum and this one is minimum. Good. Now that we understand this, you can see I've put some things up there. A is greater than 0 on the graph, and I've put into bracket positive, and then A is less than 0 on the graph, and I've put into brackets negative. Okay, you must understand this very, very well. So you can see what I'm talking about here and here. So if A is greater than 0, positive. If A is less than 0, negative. And this is an example of a function that will give this graph. You can see the A is 2, is positive. And this one doesn't look so clear. You have to rearrange. We'll get, if I write the negative x first, I get negative x squared rather first, then I bring minus 3x, then I bring plus 5. What's the coefficient of x squared? Is minus 1. So you can see the A is minus 1. Okay, so that is why it will have N shape. Good. Now that we understand the properties of the A, please, it's very, very important, because the A will tell you whether you have a minimum value or the maximum value, and you have to use it to answer questions. Let's move on to the next one. Now, a graph of a quadratic function. The graph of a quadratic function is a parabola. What is a parabola? A parabola is like this, what we just saw, like this. Okay, like this or like this. Good. Now, but we're going to see this one a lot. Okay, now, so the graph is a parabola, and we can draw it by using a method called completing the square. Completing the square. Take note of that. Completing the square. So how do we do it? Now, we can draw the graph if we know the axis of symmetry, okay, the value, and if we know the minimum or the maximum value, and if we know the x-intercept. What is x-intercept? X-intercept is where the graph cuts the x-axis. This is x, this is y. So if I draw the graph like this, you see the curve cuts the x-axis here, and then cut it here. They are called intercept. So let's say this is -2 and this is 3. Then the x-intercept are -2 and 3. We're going to learn how to find the intercept. Okay, so how do we use methods of completing the square to, or method of completing the square to draw a quadratic or graph a quadratic function? Now, let's take this, the expression, the ax squared plus bx plus c. And this is how we do the method of completing the square. You have to understand the principles. First thing is you have to make sure the coefficient of x squared is 1. But what's the coefficient of x squared there? It is a. It's not 1. So what we do is we take the a out. We have to factorize the a. So we take the a out. Okay, we take the a out, we bring bracket x squared plus bx plus c. But if we write this, when we open this, we will not get the expression up there. No, we will not. We'll get ax squared plus abs plus ac. So it will be wrong. So in order to maintain the expression, you have to divide this by a and divide this by a. So that when we open, see, when we open, we get ax squared plus a bs times bsa plus a times c over a. And you can see this one will cancel, and we get ax squared plus bs plus c. So we'll get the expression back. That's why we have to divide by a, the bs and the c. After that, follow the principle. What you do is, this b over a, you have to find half of it. So half of it is half times this gives you 1b, but we just write b over 2a. Then this is the answer. You square it. When you square it, then you add it to this one, and then you subtract it. Please, you have to follow it. You add it and you subtract it. Good. So b over 2a in the bracket square. So we're going to have a, okay, bracket s square plus bx over a. Then we add what? B over 2a in the bracket square. Then we subtract it. B over 2a in the bracket square. Add it and subtract it. Then plus c over a bracket. Then we take the squares here, s square and the b over 2a square. So we get a out, we bring a square bracket, then we bring a bracket x plus b over 2a all square. You know why we took this and we put them together all square? Because when you open this, you will get the expression here. Let's try and see. We get x, that's I want to prove it to you. X over b over 2a. Square means times itself. So x plus b over 2a. So let's multiply this by this, we get s squared, and then by this we get plus bx over 2a. Okay, then this by this we get plus bx over 2a. Then this by this we get plus b squared over 4a squared. Okay, then these two are like terms, so we put it together, we get s squared plus 2bx over 2a, okay, plus b over 2 square, a square, that's b square here, 2 square, a square. Then this one will cancel this, you see, so we get s square plus b over ax plus b over 2a all square, because there's a square, 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 all square. So you can see this expression here is the same as the expression here. That is why we take this and we square it. So please, you don't need to prove this, always remember you follow the principle, you take the squares and you square it. Good. Now, so we have a square bracket x plus b over 2a in a bracket square, and I've explained to you why we do that. Okay, relative math, we have a lot of proof, so just have to prove why it is like that. Okay, so let's move on now. So we have the square there, and then we bring, it's left with this, so we bring minus, then the square affect the b, the square affect this and affect this, so we get b square over 4a square plus c over a square bracket. Then we find LCM for this one, so we get 4a squared, that's the LCM. This cancels this cancels this, okay, one time, so we get minus b square plus a cancels the square here, okay, so we get 4a times c, 4ac. Good. Then we come down, we have a, okay, square bracket x, number brackets here, plus b over 2a square. Then watch what I'm going to do. I'm going to take the negative out and put this in a bracket b square. Then because I have factorized the negative, I have to change this sign plus to minus 4ac, close all over 4a square. You know why I have to change the sign to negative? So that if I open it, you see, this time this is this, and this time this will give you plus, because negative times negative is plus. So you have to make sure you follow the principle. Good. Now, the square bracket comes, which means the a here is multiplying everything. So we're going to get a times x plus b over 2a square, okay, minus a times b square minus 4ac all over 4a square. And you know this a will cancel the square. So finally we have a bracket x plus b over 2a square minus b square minus 4ac bracket all over 4a. Good, we have finished. Now when you do that, you have two brackets. Whatever you have in this bracket, this one, let me change the pen to show you what we have here. Okay, will give you the axis of symmetry, the axis of symmetry. Okay, and what we have in the second bracket, this one, will give you the minimum or maximum value. Do you understand? Good. We are going to apply it to solve problems, so you understand it very well. So please try to take the expression yourself and work through to see if you end up with this. You have to practice it. Please, you have to practice it to master it. Good. Now let's move on. So now it means that let's take the equation of the axis of symmetry here. You see, we have s plus b over 2a. So if we have s plus b over 2a, we have x plus b over 2a. We have to equate it to 0 to get the x. So we get x is equal to minus b over 2a. So which means the equation, this is the axis of symmetry. It passes through the turning point. It divides the graph into two halves, which means this axis of symmetry is x equals minus b over 2a, and this is also x equals minus b over 2a. Now there is something about this. Watch. You will see that at the turning point here, the values of x here will be what? Increasing. So it means the values of x increases. Okay, we say increases when x, okay, or rather the curve, the function increases, not the value of x. The function, okay, increases when x is greater than minus b over 2a. Okay, and here you can see that when you come, x is decreasing, s is decreasing, s is decreasing. So we say the function decreases. Okay, the function decreases here. Let me use arrow, it's increasing. Okay, here is decreasing. So the function decreases when x is less than minus b over 2a. You have to keep these things. Now let's come here to here. We have x, all the s coordinates here will be increasing. Okay, sorry, we'll be getting to the axis of symmetry and the graph will be increasing. Okay, so when the graph is increasing, the s value that you see here, okay, when the graph is increasing, the s value that you see here, they are less. Now watch, when the function increases, s is greater. So here, when the function increases, x is less than. So we say x is less than minus b over 2a when the function increases here, when it is a maximum, when the function increases. Okay, increasing, and here decreasing. Okay, and all the s values here will be what? Less than. So x is less than minus b over 2a when the function is decreasing. Okay, all right, please, if you don't get it, play it over and over again, try to get it. It's it is very important. Good. Now, so let's now look at this. This is a topic. Oh, sorry. This is a topic. This one. It's a topic. It says finding maximum and minimum values of quadratic functions. So two methods are used. One, completing the square. Two, differentiation. But we'll not look at the differentiation here. We are doing completing the square. So the question, what is the minimum value of 3s squared minus 2s plus 1? And what value of x does this occur? That means the axis of symmetry. So we are going to use the completing the square. So we take the question, we write 3, our question, 3x squared minus 2x plus 1. And what did we say? You have to make sure the coefficient of s squared is 1. So we take 3 out, bracket s squared minus 2x plus 1. But in order to maintain the expression, you have to divide this by 3. Okay. You have to divide this by 3 and divide this by 3. Good. Then what next? We have to find half of minus 2 over 3. Always check the sign, it's minus. It is not half of 2 over 3, it's minus 2 over 3. So half of minus 2 over 3 gives us minus 2 over 6. And when you cancel this, you get minus 1 over 3. And when you find half of it, what do? You square it, and what's next? You add and subtract. You see, relative math, you have to keep the principles. If it's a formula, you have to keep the formula. If it's a law, you have to keep the law. That's what makes math. Okay, that's what makes math. So we get minus 1 over 3 squared. So we get 3 out, s squared minus 2x over 3. Okay, then we add what? Minus 1 over 3 square, and we subtract it again, minus 1 over 3 square, then plus our 1 over 3 bracket. Then we bring 3 out, square bracket, then we take the squares. Remember, we take the squares from the general one. So remember, it's negative 1 over 3, so we get x minus 1 over 3, okay, x minus 1 over 3, 1 over 3, I want to write it well, x minus 1 over 3, okay, square, then minus, then remember the square affect this and affect this, so we'll get 1 over 9, minus 1 times minus 1 is positive, then plus 1 over 3. Then we have to find LCM for this, which is 9, and we get minus 1 plus 3. I think you understand. So this will give us 3 square bracket x minus 1 over 3, okay, square. Then this will give us positive 2 minus 1 over 3 plus minus 1 plus 3 is 2, so we get plus 2, okay, over 9. Then we bring the square bracket, but you can see the 3 outside here, 3 outside here is multiplying everything in the bracket. Okay, so we get 3 bracket x minus 1 over 3 square, then plus 3, okay, plus 3 is multiplying these two, so times 2 over 9. So you can see this one will cancel this, and we get what? 2 over 3. Good. So the minimum value is 2 over 3, and it occurs at x minus 1 over 3 equals to 0. You know, you have to equate that to 0. Let's come here. 3, we had, what did we get? We get 3 bracket 3 bracket x minus 1 over 3, okay, square plus 2 over 3. Okay, so the minimum value, we then say minimum value equals 2 over 3. If you understand the general one, this is the minimum value. And then the axis of the where it occurs at x equals to 1 over 3. You know why? Because x minus 1 over 3 equals 0. When you solve, this one crosses the equal sign, you get s equals to 1 over 3. Good, so we have solved the question. But do we always have to use the method of completing the square? Do we always have to go through all of these? All right. Do we always have to go through all of these? No, we don't have to always go through all of this. So let's see how we can do it using the general expression. Okay, so using the general expression, we said we have a bracket x plus b over 2a. You have to keep this, please, minus bracket b squared minus 4ac all over 4a. You have to keep this. You have to, as an relative math student, you must keep certain things. Good, I have proved to you how we got it. So you know this expression here will give you the minimum value, and this one will give you the x where it occurs, the axis of symmetry where it occurs. Good, so what we just do is to pick the expression. You know the expression, the a, let's go there and look at the expression. If we look at the expression, the a is what? 3, and the b is what? -2, and the c is what? 1. Good, so 3 - 2, 1. So a equals to 3, b equals to -2, and c is equals to 1. So if you want to find the minimum value, just use the expression minus bracket b squared, so -2 squared minus 4, and then a is 3, and then c is 1, bracket all over 4, a is 3. And then you do it, you get minus bracket 2 squared is 4 minus 4, 3, 12 times 1 is 12, bracket all over 4, 3, 12. Then this gives minus 4 minus 12 is minus 8. Please check the signs, maths, you have to check, you know. So 12. Then this gives positive 8 over 12. And when you cancel, 4 goes into 8, 2, 4 goes into 12, 3. You see, we have gotten the minimum value, 2 over 3. Let's go and check. When we use the methods of completing the square, we got the same thing, 2 over 3. So you can see here, see, 2 over 3. Minimum value. Very, very simple. Good. Then we can also do the axis of symmetry here. Let me draw this. Good. We said that one is x plus, okay, and then b is -2, so we have -2, okay, over 2, and then a is 3. So this gives, remember you have to equate it to 0 to solve for x. So you get s equals to, then this thing crosses the equal sign, you know you have 2, because it's negative, check, it's negative, okay, so it's negative there, and it crosses the equal sign. I want to do the negative well. So it crosses, you get 2 over 6. And then 2 over 6, when you cancel, you get 1 over 3. Didn't we get 1 over 3 when we used the other one? Good. See, here, we got s equals to minus 1 over 3. And if you solve it, you get s equals to 1 over 3. Okay? S equals to 1 over 3. That's what we got here. X equals to 1 over 3. Okay, so you don't need to do all these things. You don't need to go through all these things, all these things. You don't need to go through. If you know the general expression, when the question is given to you, you just substitute the value. You put the general expression, you just substitute the values. You know the general expression will give you 2 brackets. One, this one is for minimum value or maximum value, and this one is for the x value where it will occur. It's very simple. It's very simple. You just need to practice it. Okay, now here there's a question here. Find the minimum value of the function I this, and then I this. I want you to do this. When we meet again, we are going to solve it and you check your answers. Please, this is relative mathematics. There are certain things you need to keep. Now, let me go through the general expression again because that's very important. You have AS squared plus bx plus c. What did I say? You take the a out, you get s squared plus bx over a. You know why we have to divide by a. Okay, then you find half of b a, and half of b a, you get what? b 2a, b over 2a. Okay, and what did you do? You square it and add it and subtract it. Okay, so to the bs, so you get a s squared plus b over ax, then you add the b over 2a square and you subtract it, b over 2a square, then you bring plus c over a bracket, then you take the a square bracket, then you take the squares. We have proved this. You get x plus b over 2a square. Okay, then you get minus b square over 2a. You know the square affect this over 4a rather, please. So because the square affects top and down, so you get it affect the 2 and it affect the a. So 4a plus c over a square bracket. You find LCM. Please, the square affect the a and affect the 2. So you get 4a square. Check these things here. So you get 4a square. This cancels, you get minus b square plus. This cancels, get 4ac. Then we get a square bracket x plus b over 2a all square. Then you substitute, you factorize the negative, sorry. So you get b square minus 4ac all over 4a square. You have to change the plus to negative so that when you open, you get this back. Then a multiplies everything. A multiplies, so you get a. There's a outside here, multiplies everything. Ax plus b over 2a square minus a. B square minus 4ac bracket all over 4a square. And then the square cancels this. Okay, so we get a out, s plus b over 2a square minus b square bracket minus 4ac all over 4a. And I told you this thing here will give the maximum or minimum value. When you're given a question, you just plug them in. And then this one, you equate it to 0 over 2a equals 0. You get s is equals to minus b over 2a. When you put in the values, this will give you the equation of the isosceles symmetry where the minimum value occurs or the maximum value, this one, occurs. Good. So please practice this. And for the question, please use the two methods. Complete the square. Complete the square and then use the general expression. Put for the minimum and the isosceles symmetry. Put them in and check if you get the same. You must get the same answer. When we meet, we will continue from there. Please don't forget, this is my number. I think I've put it there on every page. So if you like the videos, you like to support me financially, please, as I try to help you, you also try to help me. You know, I'm doing these videos for you out of love. I really want to help you. But if you also want to support me financially, you can do that. I am on MTN Momo, and you can do that. I believe we have done a good job here. We will continue from here. Please try to play the video over and over. If you don't get it, try to get it, because as we move on, I may not go back to some of these things because I will assume that you already know, so that we can move faster. It is very, very interesting and very simple in studying mathematics. But for elective maths, please, there are a lot of principles, there are a lot of laws, there are a lot of formulas. If you really want to be a mathematician, keep these things. Keep them. Let them be at your fingertips. Okay? I always say in education, there are things we memorize and there are things we learn, we study, we try to understand. But some of the things we can prove it to you, but you don't need to go through all the proofs. You just keep them and use them. Thank you very much. This is our introduction to quadratic function. We will continue from here next time. Bye.